Welcome back to 5.4 on normal distribution. Let's begin. So, normal distribution, what that means, a normal curve is a symmetrical curve that represents the normal distribution. It's also called a bell curve. Normal distribution is data that, when graphed as a histogram or frequency polygon, results in a unimodal symmetric distribution about the mean. Now again, they always make these first definitions sound so complicated. But what that means is that when you look at the data, it's going to look like it's normally called a bell curve, okay? And what that means is in a bell curve, right in the middle is the mean. And then you're going to have a normal distribution of marks sort of above and below the mean, that the data will all sort of fall, for the most part, under here, okay? One spot you'll hear a lot about bell curves is if you have friends or siblings that are in university. Sometimes professors want their marks to fall within a normal distribution, within a bell curve. So they might raise your mark or lower your marks on exams or tests so that everything falls under a bell curve. So that can be sometimes frustrating if you think you've earned an 85, but the teacher uses a bell curve and suddenly you're dropped down to a 76 so that the marks fall within there. That can be very frustrating. Okay? So let's take a look at what it looks like. This is what a normal, it's like just drew there. This is what a normal distribution looks like when graphed. Again, the average, the mean is going to be in the middle, and we're going to look at how you break it down here on the next slide. My first question would be, which of these following histograms would represent a normal distribution? Okay, so as we look at these, this one's no good, this doesn't look like a bell, so that one's no good. This one's all full, that's not good. This is almost like a reverse bell curve, but not exactly right. The purple one is perfect, yeah, the purple one goes up and down, and then this blue one over here also has a bell shape to it. Those would look like normal distribution, okay? So if you ever asked which one of these would look like normal distribution, you're just looking for which ones look like a bell, okay? Now, here's the thing, and this is given to you again on a formula sheet for the exam, and I'm going to show you sort of what it looks like in a minute. For normal distribution, the standard deviation can tell you even more, okay? What it says is that 68% of the data lies within one standard deviation of the mean. 95% of the data lies within plus or minus 2 standard deviations of the mean, and 99.7% of the data lies within 3 standard distributions of the mean. Now, what does that mean? Well, let me show you. This is a chart that'll be given to you on the test, okay? Right here is the mean, right? This U, or it could be like an X with a line, whatever. That's the mean, okay? The mean, the average is always right in the middle. Then, what it's saying, what it says in the last one here, is it says 68% of the data lies plus or minus 1 standard deviation of the mean. So if you have your data, the average is right here, 68% of the results lie within 1 standard deviation. So let's say, for example, let's say your mean was 50, and let's say your standard deviation was 5. Okay, just for example. That would mean that, what would this value be right here? What's the mean plus 1 standard deviation? If the mean is 50 and the standard deviation is 5. 55. 55. And then 50 minus 1 standard deviation would be 45. So that means that if we were looking at value, that 68% of the values for whatever this chart was about, they would fall between 45 and 55, because that's 1 standard deviation away from the mean. Now it says 95% of the data falls within 2 standard deviations of the mean. Now, to get from 68% to 95%, so like these ones are each 34, and now we've got 13.5 there. So 2 standard deviations, okay, well 50 plus 2 standard deviations would be 60, and this one would be 40. So now they're telling us that 95% of the data falls between 40 and 60. All the way up to the final one is 99.7, which is nearly everything, falls within 3 standard deviations, which would be 65, right? The mean plus 3 standard deviations, and 35. And this is the type of, this chart will be given to you. It'll be attached to your formula sheet, and you're going to use this to answer your questions that I'm going to show you here in just a moment. So here's an example. Jim raises Siberian Husky dogs at his kennel. He knows from the data he has collected over the years that the weights of adult male dogs are normally distributed, okay? You want it to say normally distributed, which all of yours should, with a mean of 52.5 and a standard deviation of 2.4. Jim used this information to sketch a normal curve, okay? So here's what Jim's curve looks like. Right here, right? His mean was 52.5, and what was the standard deviation? 2.4. The mean is 52.5, standard deviation was 2.4. So Jim filled out the numbers on the bottom. 52.5 plus 2.4 is 54.9, plus 2.4 is 57.3, plus 2.4 is 59.7, and he did the same thing on the left side. He just subtracted 2.4 each time, okay? So here's the type of question you could get on an exam. It says, what percent of adult male dogs would you expect to have a weight between 47.7 and 54.9? Okay? So, 47.7 is here, and 54.9 is here. So we need the values. What percentage of dogs lie within here? From 47.7 to 54.9. Well, to find those values, we go back to our little table here. Is it easier to see on this one? No. Let me see if I can make this a little bit bigger. There we go. So here's how I do it. The mean is right in the middle. Those first 2 pieces on either side of the mean are 34%. So I'm going to go back here. Here's the mean. That means this piece is 34%. 34% of the dogs are there. 34% of the dogs are there. It's not colored anymore. Okay. Then that's the end on the right side, right? We don't need past that. But we also need to get this guy right here. Well, I go back to my little bell curve. The second column is 13.5%. So this one here is 13.5. Now, to figure out what percentage of dogs fall between 47.7 and 54.9, I just add these up. 13.5 plus 34 plus 34 is 81.5% is my answer. That's how many dogs fall between 47.7 and 54.9. Okay? Next. This one says, what percent of dogs would you expect to have a weight between 50.1 and 59.7? Okay? So you can highlight it if you want. Well, I got to be between here and here. Then you go back. Eventually you'll have this memorized, but for now we'll go back. Okay, those 2 numbers are 34 within 1% of the 1 standard deviation away. So that's 34, that's 34. I need this one and the next one So I go back to my table. They're 13.5 and 2.35. 13.5, 2.35. So those are the percentages of the dogs that fall between 50.1 and 59.7. So I just add those up. 34 plus 34 plus 13.5 plus 2.35. The answer to A is 83.85%. Okay. Question B says, what percent of adult male dogs at Jim's Kennel would you expect to have a weight of less than 45.3? Okay, so I'm going to erase this for a moment. Now, I want to be less than 45.3. So I'm looking for this little piece right here. Okay? So to help, I'm going to fill in my numbers. 34, 34, 13.5, 13.5, 2.35, 2.35. Let's go back and look for a moment at our chart. The chart says that 99.7% of the dogs, or 99% of anything in the bell curve, lies within 3 standard deviations. Okay. If 99.7% fall within there, what percentage of things are outside of that? Well, 100% is my total. Minus 99.7 is 0.3%. 0.3% is split between this piece and this piece, right? So then what's half of 0.3%? Right, 0.15%. So when the question asked us, what percentage of the adult male dogs would you expect to have a weight of less than 45.3? Well, that's this only little piece that's left. That would be 0.15%. Cool? Cool. All right. The next thing you might be asked to do, there they gave us the graph and we just got the percentages. Sometimes they ask you to sketch your own graph, okay? This is about 2 baseball teams that flew to the North American Indigenous Games. The members had carry-on luggage for their sports equipment. The masses of the carry-on luggage were normally distributed with the characteristics shown to the right. The men's had a mean of 6.35, and so did the women's. The men's had a standard deviation of 1.04, and the women's was 0.59. So it'll say sketch a graph to show the distribution of masses of the luggage for each team. Okay. So what you'd have to do here is it's just a matter of putting down the numbers, okay? The 6.35 is the average, right? That's the mean. That goes right in the middle. 6.35. 6.35, okay? Now it says that the men's has a standard deviation of 1.04. 6.35 plus 1.04 is 7, oops, I'll do it in blue. 7.39 plus 1.04 is 8.43 plus 1.04 is 9.47. Then I do the same thing on the opposite side, right? Now, except I'm minusing the standard deviation. This will be 5.31 minus 1.04, 4.27. I apologize, it's a little messy. $3.23. Okay. Then we do the same thing with the women's luggage, except now their standard deviation is smaller, so it's 6.35 plus 0.59, 6.94 plus 0.59, 7.53, oops,
3 plus 0.59 is 8.12. Same thing on the back side. Minus 0.59, 5.76, 5.17, 4.58. Okay. So there we've sketched our graphs. It was pretty easy. And then occasionally they might ask you what would it look like to show both on the same graph. We won't worry about that one too much. Now, that brings us to our homework. So we're going to be in our workbook, pages 120, 123, and I'll give you some specific numbers to try here. 1, 3, and 1, 2, and 3. Let's go with. Okay, workbook page 123, 1, 2, and 3. Thank you. Have a good day.